Hello, this video contains the solutions for 10.7 to 10.10 multiple choice practice. First problem is a little bit unusual in that there aren't a whole lot of calculator problems for Taylor series, but this is one. So let's see if we can make sense of this. Taylor series for the natural log of x centered at x equals 1 is this. And let f be the function given by the sum of the first three non-zero terms of the series. So let's go ahead and write those first three terms out, starting at 1. So the first term is going to be, let's see, 1 plus 1, so it'll be positive, and then it'll be x minus 1 over to the 1 over 1, so that'll be x minus 1. That's the first term. Second term will be negative, be x minus 1, x minus 1 squared over 2. The third term will be x minus 1 cubed over 3. Those are the first three terms. Okay, they want the maximum value of this on this interval. Well, the easiest way to find the maximum value of this, since we can use our calculator, is let's just graph this and then find the maximum value on that interval. So, hey, look, there's a, let's see what we're looking at there. That's the sine function and the first three terms of that series. That's pretty cool. But anyway, that's not what we want now. We want the natural log function. Let's click that out of there. We want to graph this. So I want to do the absolute value of the natural log function minus, and then I'm going to put my series in a big set of parentheses so the minus distributes properly through there. And that series is x minus 1 minus x minus 1 squared over 2 plus x minus 1 cubed over 3. And that, let's see, yep, that's right, that closes the absolute value sign. So let's go ahead and, well, before I graph that, I only care about the values between 0.3 and 1.7. So let's just only look at those, 0.3 to 1.7, and make the x scale, I'll just make it 1, I guess. And those values are probably okay. And graph that. And it looks like it's done. Okay, so I think that I'm going to go back and change the window because these y values were clearly way too much. Now it's an absolute value, so I guess I should set that the minimum. It can't go below 0. And let's make that, it looked like it was pretty small, so let's try half. See how that looks. So it looks like the maximum value happens right here. So I'm just going to actually trace this. Oops. I meant to do trace and just move my cursor over it. I'm interested in what the difference is, in other words, what the y value is. There it goes. Get all the way up. Oh, and we want it at x equals 0.3. Oh, there it is. Great. This looks like it's 0.145. And there it is. Now, just reflecting on that for a second, it shouldn't be surprising that it happened at one of the endpoints, because this is a series that's supposed to approximate this, right? So we were looking at an interval that's centered around 1, so it shouldn't be surprising that like in the middle of our interval it was really close and that it started to peel away from that at the edges. So it just turned out it was peeling away more over here, and that difference was 0.145. All right. Number 2, complete interval of convergence for this is, well, let's just eliminate some answers before we do anything else here. Here's an x minus 1. So what's the center of this interval? The center is going to be at x equals -1. So right off the bat, those are not possible, right? Those are centered in the wrong place. This has to be centered at -1. So it's at this point, we could do the ratio test and all that stuff, but we know it's -2 to 0, right? That's all that's left here. So we really only have to check the endpoints. So let's go ahead and check -2 and 0. So at x equals -2, when I plug -2 in here for x, that gives me a -1 in here. So that's going to be -1, that's going to make it alternate. So it's an alternating p-series. Alternating series with a p equals 2. And if the p is 2, it's going to converge whether it's alternating or not. So you could say that converges absolutely. All we really care about is that it converges. So it's got the equal sign under the at -2. So that's gone. And then at x equals 0, and if you're thinking ahead here, since it's a p-series, when you plug in 0, it's going to be the p-series at 2 non-alternating, but that still converges because it's still a p-series with a p of 2. So looks like that's our answer, E. So it saved a lot of time if you just looked at what the center had to be. It saves you doing the whole ratio test with that. Although, of course, you would get the same answer if you did that. All right, number 3. There's a 3 down here for some reason. So for -1, between -1 and 1, if f of x is equal to this, then the derivative is equal to, all right, let's see if we can figure that out. Now let's just look at these terms. Forget the alternator for a minute. What's the derivative of this? Well, the derivative of x to the something is that x we multiply by the exponent, so it would be 2n minus 1 times x to the, we knock the exponent down 1, right? Exponent comes out to the front. That's how we do the power rule, and then the 2n minus 1s would cancel. So it looks like it's going to be something times x to the 2n minus 2, which leaves only these as possibilities. So the question is just whether or not the alternating, and it looks like there's no reason why when you did the n here that should not have affected this. So I think it's just going to be this. But if you wanted to be sure, you could write out a couple terms of this and see what happens. Make sure that that's correct. So let's plug 1 into this. Plug 1 in, we get positive. We get x to the 2 times 2 minus 1. That would be x would be the first term of this. And then the next term would be a negative term. When I plug in 2, it would be -1 to the third, an odd power. And 2 minus 1, 2 times 2 minus 1 is 3. It would be x cubed over 3, and so on. So the derivative of this would be 1 minus, the 3 would come out, would be minus x squared, and so on. So let's just check and see if which one of these gives us the right one. If I plug 1 into this, we're looking for the series that gives us this, right? If I plug 1 into this, that gives me a positive first term. That's a good sign. And if I plug 1 into this, that's x to the 0, and that will give me the right sign on the first term. So it's A. So it's just a little bit of power rule and then making sure we had the signs alternating the right way. therefore, what are all the values where this converges? Well, same thing. If you think about, since it's an x minus 1 here, that means the center has to be at x equals 1. Has to be centered at 1. This is not centered at 1. This is not centered at 1, but these three are. So just like number 2, I think it was, we only have to check the endpoints. So at x equals 0, let's see what we have. If I plug 0 in for x, that gives me negative 1 to the n, so it will alternate, and it's just over n, so that's going to be the alternating harmonic series. And that converges conditionally, right? Because the harmonic series doesn't alternate, but if it alternates, it does. So that converges. So at 0, we need an equal sign under there. So that eliminates this possibility. And then at x equals 2, if we plug 2 in here, that's 2 minus 1, that's 1 to the 1, so that's just going to be the harmonic series. And that does not converge. That diverges. It's the harmonic series. So 2 is not included. So that means D is the correct answer. Number 5. The coefficient of the x cubed term in the Taylor series for e to the 3x about x equals 0. Well, e to the x, the series is 1 plus x squared over 2 factorial, etc. So e to the 3x is going to be plugging 3x in for all these. It's 1 plus 3x plus 3x squared over 2 factorial plus 3x cubed over 3 factorial. So this is the term we're interested in. So 3 cubed is 27x cubed over 3 factorial is 6. So the coefficient is 27 over 6. Dividing both of those by 3, that's 9 over 2. And that's choice E. All right. Number 6. What are all the values of x for which the series x to the n over n converges? Well, it looks like our choices are all negative 1s to 1s, or all real x. So I guess if we want to really eliminate this, we do actually have to do the ratio test. So let's see. The ratio test would give us, we want to find the limit as n approaches infinity of the n plus 1 term divided by the n term, same as multiplying by the reciprocal. There's 1x left over, which can go on the outside of the limit. And then I get n over n plus 1, and that limit is 1. So I just get x for that, and that means we do in fact get one of these. So now I have to test the endpoints. Let's test negative 1. If you have negative 1 here, you're going to get an alternating series, and it's just over n, so that's going to be the alternating harmonic series. The first term would be actually negative 1, right? Not that it matters, really, because it's going to converge. For the record, it converges conditionally, right? Because the harmonic series would not. So negative 1 is included, which eliminates that and that. So it's just a matter of whether the 1, and if we have a 1 there for x, then we just get the harmonic series, which diverges, because it's the harmonic series, p series where p equals 1. So that's going to be C. Converges when it alternates, but not when it's 1. So number 7, let f be the function given by f of x is equal to the natural log of 3 minus x, the third degree Taylor polynomial for f about x equals 2, Well, about x equals 2, that means that we want to have an x minus 2, right? And keep in mind that we know, one of the series that we know is that the natural log of x plus 1 is equal to x minus x squared over 2 plus x cubed over 3. This is one of those series. This is one of the not so big 2, right? Natural log of x plus 1 and tangent inverse. But it's worth knowing. It will help you out if you know those. So can we somehow rewrite this as one of those? Let's see if we can do that. So what are we substituting in for the x? So we're substituting, we want to have the natural log of 1. If you think of this as 1 plus x, this is like 1 minus x minus 2. All right, notice how that will give you the 3 that we want. So that's a little bit of a trick there. And then that means that instead of x, we're plugging in negative x plus 2 in everywhere here. So that gives me negative x minus 2 minus negative x minus 2 squared, but squaring that just gets rid of that sign, right? Just makes it positive, over 2 plus negative x minus 2 cubed over 3, and cubing the negative sign does make it negative, so it looks like they're all minus. So that looks like it matches up with it. Does not alternate. They're all negative. That looks like this. All right, a little bit tricky there to figure out what to do with that series there. Number 8. Interval of convergence for this. Well, here we go again. We know that the center must be at x equals 1. So we must have an interval that's centered at 1. That's centered at 0. That's centered at 0. That's centered at 0. But these two are centered at 1. So all I have to do is check the endpoints. So let's see. If I plug in negative 2, negative 2 minus 1, that would give me the sum. Let's see, negative 2 minus 1 is negative 3, or n for 3 to the n. Well, let's see, that's going to alternate. When I plug in 0, that's going to give me 1. When I plug in 1, I'm going to get the same number top and bottom, but this will be negative and that'll be positive. So that'll give me negative 1. That's going to give me this series, which diverges. So at negative 2 it diverges. It does not include negative 2, and that's enough actually to get us this answer. But just for the record, we can check 4. If I plug 4 in, that gives me 4 minus 1 is 3. That would give me the sum of 3 to the n over 3 to the n, and that's just going to be 1 plus 1 plus, so that's always equal to 1. And of course that diverges also. So see, I guess this answer is there for if in case somebody accidentally, mistakenly thought that this converges to 0, but it does not because the terms are not approaching 0. All right, last one, another calculator problem. The graph of the function represented by the Maclaurin series, this intersects this graph at x equals. So we're looking for the intersection of y equals x cubed and whatever this is. This is a matter of looking at the series and recognizing what it is. What is this series? Well, it looks like the e to the x series, but it alternates. How do you do that? How do you get the e to the x series to alternate? You plug in negative x instead of x. So with a little bit of experience, you learn to recognize that This is almost the e to the x series, but the signs are alternating, so that's e to the negative x. And now it's just a matter of finding the intersection of those. And let's go ahead and do that. So we want to find the intersection of x cubed and e to the negative x. And graph, let's see, let's go ahead and go back to the standard window. There's the intersection. Second, calculate the intersection of these two curves. So they intersect at x equals 0.773. That's choice A. All right. So not too bad, right? And I'll tell you a little secret. When I went through and made this multiple choice practice, I took the most of what I thought were the easier ones and saved those for your test. A lot of them are very similar to this, but I thought maybe those calculator ones, for example, were a little bit different, maybe a little bit harder. So if you can do all those, I think for the multiple choice part of the test, you will be in fantastic shape. And if you have struggled with those a little bit, then I would spend some time studying these, and then you'll be in good shape. All right.